Okay, and to finalize, let's talk a bit about additional materials for VLC. In summary, I've included here some of them: polarizers, birefringents, and retroreflectors. So let's talk a bit about polarizers. Well, a light by default is completely unpolarized. Okay, it means that photons are agitated in any direction, but they can go through a linear polarizer filter in order to create a completely polarized light. Okay, so if the input of this light is completely unpolarized, the intensity of the output of the light is the half of the intensity of the input of the light. Okay, and this is measured through thanks to the Mallows law, and also it depends on the angle that the polarized signal and the linear polarizer has. Okay, is creating. So there are many applications to be used by these polarizers, transmit and receive data in a specific polarization in order to reduce the interference. Because if we know which is the polarization of the source of the signal, we can receive the signal in a better way. And also they are used in the 3D glasses for the cinema. The same for birefringents. I have included here some pictures in which we can identify what is going on in this process here. So it means that if one input ray is impinging this material, two rays are in the output. Okay, so we are splitting one ray into two. This is what is seen here. Okay, so the radiance angle and the intensity of the output light depends on the material that is used for these birefringents. Okay, this is also made by the Snell's law and so on and so forth. Also, the intensity, of course, it decreases because of the characteristic of the fine birefringence material. And some applications can be used for 3D glasses in order to emulate the vision of a human eye, and also some positioning techniques, such as in this source over here. So they are able to see what is going on in the surrounding in order to create some positioning techniques. Okay. And just to finalize, these are also retroreflectors, can be used. Well, I have included here a retroreflector, which is in most of our bicycles we have in the back in order to avoid some collisions with some cars and so on and so forth. And what they are basically doing is to reflect the signal that is impinging into them. Okay, they are reflecting the signal in a passive way. So the way that is impinging, for example, here in this schematic here, I've included, let's say, that it's good to construct an IoT scenario, because imagine that all these devices has a retroreflector into it, and by using some LCD shutter, we are able to send through the uplink some unique identifiers. Okay. So this way we can use it for positioning systems and so on and so forth, as they do in this source over here. So to finalize some application, positioning systems, also for creating a backward channel with low data rate, and to build some passive communications. Okay.
Can we use the retroreflectors for non-line of sight communication, VLC?
It's quite difficult because you have to. It's completely necessary to have a line of sight in order to reflect the signal in the same way. If you don't have a non-line of sight between the source and the receiver, of course you will receive some power to this retroreflector, but it's going to be quite difficult to get it back through the uplink. Okay. There are some ESRs that are working on that by using some natural light. So it's going to be really interesting also to see how this technology evolves. Okay. So that's all. As a conclusion, we have discovered some important elements for both transmission and reception. We have talked about the characteristics of such devices in terms of communications, and some additional materials were introduced. So I'm very happy to answer some questions in case you have.